In this video, we're going to look at the quadratic formula and how to use it to get your values for x. So if you remember from the original quadratic equation, it is in the standard form ax squared plus bx plus c equals 0. And when you use some tricky algebra and isolate the x from this formula, you get your quadratic formula, which is in the form x equals minus b plus or minus square root b squared minus 4ac, and all of that over 2a. And there you have your quadratic formula. And when you look at the quadratic formula, you can see that there's a square root, and under the square root it is b squared minus 4ac, which is also called the discriminant. And you can use the discriminant to see if you have two real solutions, one real solution, or no real solution, which just basically means that you can see if you get two x values, one x value, or no x value. So your discriminant can also be written as a triangle. And with this, you can see what the roots are or how many real solutions you have. So when b squared minus 4ac, the discriminant, is more than 0, that means that you have two real solutions, which basically means you have two values for your x. When the discriminant is equal to 0, that means you have one real solution or one value for x or a repeated root. When your b squared minus 4ac is less than 0, that means you have no real solution. And the reason for that is you can't have a negative number underneath a square root. It's impossible. It's an imaginary number. It doesn't work. That means you have no roots. So we can move on to the first example. And the first step is always to put it in the standard quadratic form. And how you would do that is as follows. You put a negative 5 on both sides to cancel out the 5 on the right hand side. Which will give you this. And now you can see it is in fact in the standard form. With your a being 1, your b being 2, and your c being negative 5. Now what you can do is, in the second step, is to work out the discriminant to see if you can calculate the values for x and how many values for x it will have. So you can just write down your discriminant again, and now you substitute your values in. For your b, for your b, you have 2. For your a, you have 1. And for your c, you have negative 5. And all of this will be 24. So that means that the b squared minus 4ac is more than 0. So this is more than 0, which means that you will have two real solutions. Now, I would go back and write the equation again. Now you want to check and see if you can factorize this. If you can't factorize it, then you should use the quadratic formula to get your two values for x. So I'm going to write down the quadratic formula. There you have your quadratic formula, and now you can substitute all of your values in as follows. So you get your b as 2, then plus or minus the square root of b again, which is 2. Don't forget the square. Then minus 4. Your a is 1, and your c is negative 5. All of this over 2a. And a is 1 again. Now how you would calculate this is you would put all of this in your calculator. And over here, for your first x, you would use plus, and then for your second x, you would use minus. That's how you get two values. So with the plus one first, you would get negative 1 plus the square root of 6, which if you round it off to 2 decimals, you get 1.45. And then with the minus, or your second x, you get negative 1 negative square root of 6, which is then, if you round it off to 2 decimals, negative 3.45. And there you have your two values for x. Now, if you think in terms of a graph, the quadratic equation is a parabola. And now you have your two x values here. So if I can just quickly explain, you have your x-axis over here and your parabola. This basically means that the point over here is going to be where x is negative 3.45, and over here your x would be 1.45. That's how you find your roots, and that's why we want to calculate the x values. Moving on to the second example, you can see that it's already in standard form. And if you look at it, what you should ask yourself is, can I factorize this? Because if you can factorize this, then you don't need to use the quadratic formula. And as a matter of fact, you see that, yes, you can factorize this. And its factorized form is x negative 3 in brackets and x negative 3 in brackets again, which is the same as saying x negative 3 and all of that squared is 0. So then x would be equal to 3. And you only have one value for x. That means that the discriminant will be equal to 0. And that means that it's a repeated root. But you can still use the quadratic formula to get your values for x, which I will show you how to do it. So in standard form, your a would be 1, because there's a 1 in front of the x squared. Your B is going to be -6. And your C is going to be 9. So for interest's sake, if you work out the discriminant, which we already know is going to be equal to 0, because we can only get one value for x, but just to show, so b squared is -6 squared minus 4. Your a is 1. Whoops. Your a is 1. And your c is 9. When you simplify this, you get 36, -36, which is 0. And that means that you only have one real solution. Now, if you want to use the quadratic formula to calculate it, it will be as follows. Let me just write out the quadratic formula. There you have your quadratic formula. And what you do now is you substitute all of your values in. But remember, because you only have one real solution, it doesn't matter if you do plus or minus, because you will get the same answer. So I'm just going to use plus, and I'm going to substitute the values in. You get your minus b get your b squared your a is 1 and your c is 9. Over 2, and yet again your a is 1. So if you plug all of this into your calculator, you would get your x value as 3, which, if we go up, is the same answer we got when we factorize it. So this is also a way of checking to see if you factorize correct. You can use the quadratic formula to see if you have the same answer. And if you only have one value for x, that means that your graph is going to look like this. It is going to touch the x-axis there at x equals to 3. And that's also why they call it a repeated root. So we move on to the final example. And yet again, your first step is to write it in the standard quadratic form. And how you would do that is as follows. You get everything to the left-hand side. And now plus 5x to get rid of it, and plus 5 to get rid of your constant. And what you do on the one side, you do on the other side. So these will cancel out on the right hand side, and then you will be left with x squared plus 4x plus 5 equal 0. And as you can see, now it is in the standard quadratic form, where your a is 1 again, your b is 4, and your c is 5. Now, before using the quadratic formula, you need to check and see if you can factorize your equation here. But you can't factorize it, so now you have to use your quadratic formula. But firstly, just before you use your quadratic formula, you want to find the discriminant. B squared minus 4ac. When you plug all of your values in, B has 4, A has 1, and C has 5. And when you calculate this, you get 16, negative 20, and you get negative 4. And if you remember correctly, when your b squared minus 4ac, or your discriminant, is less than 0, which in this case it is, then you have no real solution. That means that you don't have any values for x which would satisfy the expression. So you don't need to use your quadratic formula, because your b squared minus 4ac is equals to negative 4. And when you put that underneath a square root, you get an imaginary number which is invalid. So it would not work. And if you want to visualize this graphically, let's say this is your x-axis. Then your graph would look something like this. It doesn't cut the x-axis at any point. So there's no real solution. There's no values for x. Thank you so much for watching, and I hope that you know a little bit more about quadratic formulas now.